You're here because you want to master carboxylic acids and esters with a University of Cambridge graduate. Hi, I'm Brendan, and I'm a University of Cambridge graduate who has been teaching chemistry to many students like you over the past 9 years. I'm also the founder of the Chemistry Institution, where we have helped many students improve in a short amount of time and achieve the grades of their dreams. Be sure to check out our website in the link in the description below so that you can download a free copy of the notes for yourself and use it to run through this lecture with me today. Now we're going to talk about carboxylic acids. Some simple examples include methanoic acid, so 1 carbon with COOH, ethanoic acid, which is 2 carbons long, or propanoic acid, which can be 3 carbons long. So this is the start of the homologous series of your carboxylic acids. Chemical formula, this is HCO2H, this is CH3CO2H, and then this one is CH3, CH2, CO2H. So as you can see, these carboxylic acids have the typical CO2H functional group. This general formula is CN, H2N plus 1, CO2H. How do you prepare your carboxylic acids, or what reactions can form your carboxylic acids? Well, we already ran through one. This is under your alcohols chapter. You can use oxidation of your alcohols. So just to recap, you can use acidified potassium dichromate 6 or K2Cr2O7 and heat under reflux. If you use that, your orange dichromate 6 will turn green. How you memorize that is DOG, dichromate orange to green, or in short, DOG. You can also use acidified potassium manganate 7, KMnO4. Heat it under reflux with the alcohol, and your purple KMnO4 will turn green. How you memorize this is MPC, MyPetCat, or in short, for manganate, purple to colorless. Your alcohol will be oxidized and turned into a carboxylic acid. For example, ethanol, oxidized to ethanoic acid. What are some properties of your carboxylic acids? Well, for starters, it is a weak monobasic acid. An equation would be, for example, using ethanoic acid. Since it is weak, you use a reversible arrow to show the partial dissociation in water of this compound. And it is monobasic, which means that each molecule of this acid will typically yield 1 H+ ion. It can also exhibit typical acidic properties. Because it's an acid, you can expect it to react with alkalis or bases. For example, your ethanoic acid can definitely react with NaOH to form CH3, CO2, and A. Take note, reactions of weak acids doesn't mean that the arrow will be a half arrow, it will be a full arrow over here. It's only the dissociation of the carboxylic acid that will give the half arrow, because it is a partial dissociation of the weak monobasic acid. So a common question that comes out is, why does this solution of ethanoic acid dissolved in CHCl3, which is an organic solvent, not turn blue litmus paper red? Well, this is entirely because while it is an acid, remember, acids only dissociate to give H+ ions under water. If you use an organic solvent, it just simply exists as a simple molecular structure where no dissociation occurs, and so you don't have H+ ions, which will therefore not turn your blue litmus paper red. Of course, your ethanoic acid can react with carbonates as well. For example, if I were to give CH3CO2H, two of this can react with sodium carbonate over here to give H2O plus carbon dioxide and plus your CH3, CO2, and A. 2 of these. They can also react with reactive metals. Let's say I add a reactive metal of magnesium. You need 2 of this, and you can produce H2 gas, plus you will get CH3, CO2, 2 of these with magnesium. And as stated before in the alcohols chapter, your alcohols can also react with carboxylic acids to give your esters. Raging conditions are concentrated H2SO4 as a catalyst. For the reaction, you're going to refer to the esters chapter that is ahead for the drawing and the naming of esters. Yes, we have been talking about how alcohols and carboxylic acids can react together to form your esters. Now let's dive into what exactly esters are. Esters have a general formula of RCO2R'. Sometimes we use this R as a way to denote alkyl groups, which may be the same or they could be different. These are in general just carbon-containing groups. Esters are sweet-smelling liquids or solids used to make perfumes or artificial flavorings. In fact, fruits, which are very sweet-smelling, typically produce this organically. First of all, we need to know how to name our esters. For this, the alkyl derivative from the acid, there's a typo here, will come first, then the part from the alcohol. How do you remember this? Is acid has an AC and alcohol has an AL. Alphabetically, the acid should come first. So, some example equations to drawing your esters are your propanol plus methanoic acid reaction. So let's draw propanol out first. And for this, it would be preferred if you point the OH group with the COOH group from the methanoic acid. Once you do that, you can start to do the boxing. So this box will take up the OH from the carboxylic acid group and the H from the alcohol group. This is also a reversible reaction, so do take note that a reversible arrow is required. H2O will be produced as the byproduct, hence why I boxed it up. And the remaining product is just both the alcohol and the carboxylic acid remaining parts combining. So everything will stay the same, except that these two will now combine. And there you have it. This is the ester that's formed. As for how to name it, since the alkyl derivative from the carboxylic acid part, which is the C double bond O part, will come first, there's only one carbon, so this is methyl. And then the other side has 3 carbons, so this is propanoate. It will follow this pattern. Let's look at another example. Ethanol plus propanoic acid. So again, it would be preferred if you point the OH to the COOH group of the propanoic acid. When you do this, you can do the boxing up now. The H from the alcohol is going to be boxed up with the OH from the carboxylic acid group. Remember, this is a reversible arrow. H2O comes out as a byproduct, and you combine the rest. Everything else will stay the same. Once that is done, you can proceed with naming. You want to start with the part from the carboxylic acid. This is 3 carbons long, so this is propyl. And the other part is 2 carbons long, so it's an eth, ethanoate. And that is how you name the product of your ester. How about the reactions of your esters? While you can produce esters via a condensation type of reaction, your esters can also do the reverse, which is hydrolysis, using water to break up the ester group. So, if I want to find out the products of the acidic hydrolysis of your ethyl propanoate, I'm going to draw out the ethyl propanoate first. Ethyl, so there's 2 carbons on the side with the C double bond O, and then there's 3 carbons on the other side. It's going to be water, and we're going to just break up this bond over here, which is the main ester bond, and then we're going to add in the OH and the H. So with that, you will form back your propanoic acid and your propanol. And those are your 2 products from the hydrolysis reaction. Now, if they ask you for the basic hydrolysis, what it means is it's still a hydrolysis reaction, but it's in a basic medium. In other words, there's like alkali involved too. Sometimes NaOH is used. In those cases, you want to draw out the hydrolysis as per normal. So propyl methanoate over here is 3 carbons long, and the double bond O side, followed by 1 carbon over here. We're going to add H2O, and drawing downwards, we're going to break apart the main ester bond over here. So this will produce your propanoic acid So everything else remains the same. And add a H back here. So this is your methanol. But this is a common trap. Remember, this is basic hydrolysis, means there's alkali involved, so you can't really produce a carboxylic acid from this reaction. The carboxylic acid is going to be neutralized by the base. So what's going to happen is it'll become an anion instead, with the cation from the base itself. That's all for today's video. If you really learned something and you like this video, be sure to click on that like and that subscribe button so you don't miss out on free content like this. If you want to join my community of students at the Cambridge Institution, be sure to check out our link in the description below so that you can sign up for a free trial class today. Here you can learn the exact systems that we use at the Cambridge Institution to help our students improve in a short span of time and also achieve their grades of their dreams in the end.